All right, welcome back. We've made it to the final step out of 5, and this is probably the most important step when it comes to improving, becoming a better developer. So we've understood the problem, we've talked about concrete examples, broke it down into steps, we solved it or simplified it to help us solve it, and then once we have something, whether it's an amazing solution or super scrappy, it's time to look back and refactor. I know it's tempting that once you have something workable, something good enough, that does what it needs to do, it's tempting to just, shut your laptop or close the book and go, play video games or do something else. It's really tempting because often you can get by with something that just works. And in a lot of jobs and a lot of scenarios, all that matters is that something works. It doesn't have to be beautiful. It doesn't have to be the most efficient code on earth. But it's really, really important to strive for those goals. Obviously, if you're a one-man team or a one-woman team and you're creating a company on your own and you have a deadline of tomorrow and you have to just write code that works, then yeah, it's fine to be scrappy. But it's really important to try and improve your code. And it's a missed opportunity if you don't take the time to look at your code, look back and reflect on it. And I don't just mean, longingly in a poetic way. I mean, look at the individual components line by line. Talk about the parts you don't like, or what do you not like about how the code itself looks, how it reads, how easy it is to understand. Obviously, what most people care about is efficiency when they're looking at code, but there's often a balance that needs to be struck too between those two polars of efficiency and legibility. And in an interview setting, it's really important to ask these questions often out loud. You have a finished solution. You can be proud of that. Something works. I like to then take a moment and sort of go line by line and think, this is not ideal. I think maybe there's a better way of doing this, but I'm not confident. I would Google if there was a faster way of doing this, that sort of thing. So I'm going to go through that. But here's sort of a checklist of questions you could ask yourself. Can you check the result? So that one's obvious. We need to make sure our code works. Can you derive the result differently? So this is referring to the fact that there's rarely one solution and only one solution to a problem. So can you think about different approaches? Now that you've solved it one way, is there another way that seems viable that you couldn't think of earlier? Can you see it at a glance or understand it at a glance? So how intuitive is your solution? Does it make sense when you look at it on paper, on a whiteboard, in your code editor? Can you use the result or method for some other problem? One of the great benefits of solving a problem is that it helps you sort of develop a spider sense, an intuition for solving other problems. So whenever you write down a solution, it's worth pausing and asking yourself if there's any similarities between this solution or this problem and others you've encountered in the past. So maybe not in an interview setting necessarily, but this has happened to me a couple times. I solve some problem and it sort of unlocks the solution to another problem on a different project or a different company or something like that. So it's something to keep in mind. Okay, next up, can you improve the performance of your solution? So this is one that, like I said, is probably at the top of a lot of people's minds when they write a solution. So how can we make it perform better? Mainly, time complexity and space complexity. And that's something we talk a lot about in this course. So if you're not super comfortable measuring that or calculating it, that's okay. But we can still identify certain things that might be poorly performing or slow. For example, like a bunch of loops that are nested. Try and avoid that. Can you think of any other ways to refactor your code? If you're working for a company, does your code follow company guidelines, a style guide? Does it follow conventions of the language? Is the spacing consistent? Just minor things, but this is important to show, even in an interview setting, at least acknowledge the fact that your code isn't neat and that you would prefer to make it neater if you didn't have time. And lastly, how have other people solved this problem? So in an interview setting, often, the interviewers ask the same question to many different candidates. Some companies I've seen have used the same question for years. And so they've probably seen a lot of candidates and a lot of solutions. So in an interview, it can be really beneficial after you have something, whether it works or doesn't work, at the end to pick their brain. Say, what other approaches are there? What did I miss? How have you seen people solve this? And sometimes people like to share the most effective or simplest solution. Other times, people like to talk about the craziest, most eccentric solution, the most unexpected way of solving it, even if it's not the most efficient. But you can learn a lot from looking at how other people have solved the same problem. Now, if you're on your own, you're working on a project, an application, and you're solving a problem, often You're solving something that other people haven't solved before. Otherwise, you may not be prioritizing solving it yourself, right? If you need to, you're not going to build your own database from scratch. You can use someone else's database. But sometimes there are certain things that you do implement on your own, and it's worth looking at other implementations, whether it's in a different language. This happens pretty frequently to me. If I'm writing something, you may not find it in JavaScript. You can search around and you might find someone else's code in Java or in Python. And you can take that and compare it to yours, depending on how comfortable you are doing that. And it can be really useful, and you can find ideas and different approaches. Anyway, so these are a lot of questions here that you can ask yourself. But my point is that refactoring is really important. And it doesn't even have to be refactoring, which is why I called it look back and refactor. Because sometimes you could be happy with your code, or you might not want to make changes, but it's worth thinking about it. It's worth analyzing your code and reflecting on it, looking back on it, rather than simply writing something that works and calling it a day. So let's go through a simplified version of that process with my solution here. So I changed my solution a bit. Here it is, by the way. Everything's the same as what we saw in the last video. I added in a simple regular expression to test if a character is alphanumeric. So if it's a lowercase a through z or a 0 through 9. And this is how I'm weeding out all the non-alphanumeric characters, spaces, underscores, dashes, periods, commas, and only doing the letters and numbers. And I lowercase it first, and then I test each character. So if we make it to this point, the character is either a number or a letter. And then we just check, like we did in the last video. If the character is already in that object, meaning it's greater than 0, it's set to 1 or 2 or 3, for example, just add 1 to the value. Otherwise, initialize it to 1. I'm not sure where that extra 1 came from. And then we return the object at the end. So this works. And if I finish this at the end of an interview, this was my solution. The main pain points, the things that I would point out, there's a couple. One easy fix is I'm not really a fan of using a for loop. Obviously, for loops are great and they've been around forever. But in today's landscape, I would probably use a for of loop just to simplify this so we don't have to work with I. Because if we do for of on a string, it gives us each character immediately. There's no reason to go, this is an extra step. Loop through a range of numbers, then take that number to get an individual character when I could replace it. So I'll refactor this, just keep this here, but slowly refactor it down here. And this isn't really a performance thing. It's just aesthetics, I guess. So I'd say var char of that string. Then we don't need to define char again. We're going to lowercase it. So let's do this. Char.toLowercase. So we no longer have to do string of I. We're just working with char. And this should work still. Let's just verify that. So I paste it in. Let's do it on hello, hi, and throw in some punctuation. And it looks like it's working. We have 2 H's, lowercased. Okay, that's all good. Now a small syntax change that we could make. This isn't a huge deal, but this kind of bothers me when I look at it. It takes up a lot of space to do a very simple thing. We're either adding 1 to a number or setting a number to 1, or initializing a value in a key. Oh my gosh, in an object, or initializing the value to 0. So we're initializing it to 0 or adding 1 to it, which is a pretty simple thing. And it's a simple if else. So often I look to combine these into a single line if possible. And it can be difficult if you're in a stressful interview situation. Often I just write this first thing that comes to mind, the simplest, most basic syntax, and then come back and clean it up. So we can replace this here with this line. So what this does is it takes a character like A, accesses the corresponding value in our object. So if it's truthy, we're going to add 1 to it, meaning if there's a value in there already. If there's nothing in there, we're going to set it to 1. So we basically have 2 scenarios. Object char equals this, object char plus 1, or if it's falsy, set it equal to 1. So this is a nice way of cleaning up our code, shortening it quite a bit. And just to verify that it still works, one more time, paste it in correctly, and it looks like it's working. So the last thing, and this is probably the most important thing that I would think about here, we did a couple stylistic changes. we could use some more ES 2015 syntax, replace var with let and const, and that's probably a good idea to do. But the most pressing thing in my mind that I'm unsure about, if this was in an interview setting, I would say, okay, well, I'm using a regular expression here because I know how to do that, and it's a quick way, a relatively short way of checking for a certain pattern, in our case, to see if a character is alphanumeric, a letter or a number. But I'm not sure how efficient it actually is. And I would say that. I'd say, I've heard certain things that in JavaScript, and this is true, in JavaScript, regular expressions, the performance can vary depending on what you're doing and depending on the browser that you're in. In particular, Chrome had some issues with regular expressions a while back. So I don't try and avoid them because they can be very useful. But for something like this is a very simple usage of a regular expression. Often people will use them to find patterns like credit card patterns or phone numbers or addresses or much more complicated things like matching a URL pattern, which would be a huge pain otherwise. But just checking if something is a letter or a number, I think there could be a better way to do this. So I would say that out loud, and this might not come to mind right away. It didn't come to my mind right away either. But what you can do, and I just did some research to figure this out, is use char at or character at. So if we, take a string like hi, and then do char code at rather than char code at, and give it an index, it gives us a number, 104, which is the character code for h, for lowercase h. If we did, let's just do I, it's 105. Hij comes next in the alphabet, it's 106. So these are in a range of numbers. And so what we could do is replace our regular expression with using a simple mathematical comparison. So we would do a character or char code at and give it, let's just say always 0 for now. And then we would check if it's a valid character code. And I found someone doing this online, which is what sort of inspired me to look at this. This person wrote a little bit of a performance test where they're testing if something is alphanumeric down here using a regular expression. And here they're testing if something is alphanumeric using a character code. So you can see between 47 and 58 are the numeric character codes. Between 64 and 91 are uppercase alphas, I guess, the alphabet. And lowercase letters are 96 to 123. So we can just quickly, a couple Boolean comparisons, which are very, very easy and fast to do in any programming language. They're pretty much one of the simplest, if the simplest operation you could do, are these simple Boolean comparisons. And this person demonstrates actually that if you repeat this over and over and over again, you can see that the non-regular expression version is indeed faster. 55% slower using regular expressions. So I'm showing this to you not to say, I would have come up with this in an interview because I probably wouldn't have. I might have considered it, but I certainly wouldn't know the character codes. I would have just gone with what I felt most comfortable doing. But then I would, at the very end, add a little note in to my interviewer saying, hey, maybe there's a better way. I would Google it. I have a feeling regular expressions might not be the fastest way. So what I did is actually turn this into a function called isAlphanumeric, but it works in a single character. So you pass in a character one at a time, and then we get the character code at index 0 because it's a one character string. Technically, you can actually leave this blank and it still works, but I like to be explicit, so I'll put the 0 in there. It gives us the first character, which is the only character. So if we're passing in hello like this, I would call isAlphanumeric on H, call it on E, on L, and it should return true every time. And then if we have a space or an exclamation point, it will return false. So I've created this function. Now what I'm going to do is get rid of this regular expression and refactor it to be if is alphanumeric of character, just like that. Another thing to consider is the placement of when we do the lowercasing. Is it better to lowercase everything at the beginning, the entire string, and then check each character to see if it's alphanumeric? Is it better to first check for alphanumeric characters so that we weed out all the spaces, the punctuation, everything that's not valid, and then lowercase afterwards? And I'm actually not positive. on how I feel about it. I've gone back and forth. It depends on what your strings look like, what the inputs look like. If they are generally all alphanumeric versus if you have really weird strings that have a ton of random characters that aren't alphanumeric, I think that the answer would depend on that. But what I'm going to do is just run it like this. So if is alphanumeric, then we'll lowercase it and then add it into our object. So I like this solution. One, I like having this separate function so that this is pretty readable in my opinion, like for each character of our string. Like that's very nice and legible. For a character in the string, if that character is alphanumeric, we're going to lowercase it and then add it into our object or initialize it to 1 or add 1 to the current value. So I like this solution. I think it's clean and readable, but also allegedly, at least according to some stuff we found online, is more efficient to use character codes compared to a regular expression like we had up here. So I know this is getting a bit long, but I just wanted to show you my process. This is the solution I wrote first, and then I kind of just thought about it more and did some more research. And this is the solution I prefer, not just stylistically, not just because it's shorter. It's actually not shorter because of this code here. Of course, you could put all of this code right in here and not have a separate function, but I think it reads so much better like this. All right, so let's make sure it works. Char count of, sure, this one again. Hello world, hi. So there should be 2 H's. There's 1 E, what else? 3 L's, and we're ignoring case, and also we're ignoring non-alphanumeric characters. All right, so that was a lot there. Hopefully you agree. Maybe you don't. I have some feedback on my refactor, but just in asking myself those questions about how did other people do this? How could I improve this? Where are the stylistic changes I could make? Our solution looks vastly different than it did before. Not that there's anything wrong with this one out of the box. Okay,